We have confirmation on the incoming threat. Deploy countermeasures immediately.
Acknowledged, Commander. Rerouting power to the shields.
In modern peer-to-peer conflict, heavy lift mobility is the deciding factor between a reinforced front and a collapsed flank.
As threats evolve, legacy platforms face weight growth that compromises their ability to operate in hot, high-altitude environments effectively.
The CH-47F Block II emerges as Boeing's answer to the U.S. Army's demand for increased payload and structural longevity.
While the airframe silhouette remains iconic, the engineering underneath represents a fundamental shift in tandem-rotor power management and lift efficiency.
Welcome to Capeville Warfront. Today we analyze the Block II Chinook, dissecting its technical gains against its logistical burdens.
To dominate the 21st century battlefield, a helicopter must be more than a truck. It must be a survivable digital node.
The Block II was born from the realization that current airframes were reaching their maximum structural gross weight limits. With a focus on the 4,000-pound payload increase, the U.S. Army aims to regain tactical flexibility in multi-domain operations. However, increased capability brings questions. Is the cost per flight hour sustainable in a period of tightening defense budgets?
Can the Chinook's 60-year-old design truly keep pace with next-generation tilt-rotor technology entering the combat theater today?
We must evaluate if this platform is a necessary evolution or a legacy bridge to an uncertain future aviation.
To understand the future, we must look at the mechanical heart of the machine, the advanced Chinook rotor blade.
This single component was designed to provide an additional 1,500 pounds of lift, yet it faced significant technical hurdles.
Why did the U.S. Army initially hesitate on the ACRB? And how does the Block II survive without it today?
The answer lies in the trade-off between pure lift performance and the airframe's internal vibration stability during high-speed transit. Strategically, the Block II ensures the heavy lift fleet remains viable until the 2060s, a remarkable longevity for any aircraft.
As we transition to the battlefield context, we see how these upgrades manifest in real-world combat logistics scenarios.
In the following chapters, we will break down the precise cost-benefit ratio of this multi-million-dollar heavy lift modernization effort.
Every bolt, every circuit, and every blade tip has been reconsidered to maintain dominance in the vertical lift domain.
The strategic frame is set. The Chinook must evolve or become a relic of a bygone era of warfare.
What is the status of the northern flank?
We are holding the line, sir, but the Red forces are increasing pressure here.
Modern combat zones are no longer permissive environments. They are dense webs of electronic warfare and shoulder-fired anti-air systems.
For a large, slow-moving target like the Chinook, survival depends on advanced infrared countermeasures and integrated digital situational awareness.
The Block II's increased payload allows it to carry more fuel and armor, extending its time on station in high-threat sectors. In a tactical airlift, the ability to transport an M777 howitzer with a full crew and ammunition is essential.
How does the Block II manage the extreme stress of a 22,000-pound external load in the thin air of Afghanistan?
By utilizing a new drivetrain and strengthened airframe, the Block II handles higher torque without the risk of structural failure.
On the battlefield, time at the landing zone is the most dangerous variable for any air assault commander.
The Block II's digital flight control system allows for precise hovering even in brownout conditions, reducing LZ time significantly. If the Chinook is spotted, can its updated defensive suites defeat a modern IR-guided missile in mid-flight?
Statistics showed that 80% of helicopter losses in recent conflicts are due to ground fire and unguided RPGs.
To counter this, the Block II features ballistically tolerant flight controls and redundant hydraulic systems for increased combat resilience.
Logistics is the lifeblood of the division. The Chinook is the primary artery for fuel, food, and ammunition. Failure in the heavy lift mission results in isolated units and stalled offensives, a risk no general is willing to take.
The Block II's increased gross weight capacity of 54,000 pounds provides that critical margin of safety in extreme conditions.
However, the sheer size of the Chinook makes it impossible to hide, requiring escort from AH-64 Apache gunships.
This interdependency creates a complex aerial ballet that requires high-bandwidth data links to coordinate effectively in real time.
Is the battlefield utility worth the nearly $10,000 cost per flight hour required to keep the Block II airborne? When compared to ground convoys, the Chinook's ability to bypass IED-laden roads makes the cost an acceptable strategic premium.
Tactical flexibility is the hallmark of the Block II, allowing commanders to move assets that were previously ground-bound.
We now move from the where and why of the battlefield to the how of its mechanical soul.
The heart of the Block II is its upgraded drivetrain, designed to handle the increased torque from the T55 engines.
This powertrain transmits nearly 10,000 combined shaft horsepower to the tandem rotors via a complex series of 5 transmissions.
Each transmission in the Block II features improved lubrication and cooling, allowing for longer operations at maximum power settings.
The most controversial upgrade remains the advanced Chinook rotor blade, which utilizes a sweep-tip design for better aerodynamic efficiency.
While the Army paused the blade's rollout due to vibration issues, the Block II airframe is fully compatible with future iterations.
Structural integrity is achieved through single-piece machined frames, reducing the parts count and the potential for corrosion or cracks.
This manufacturing shift increases the airframe's life by thousands of hours, ensuring the Block II can serve for decades. Inside the cockpit, the Common Avionics Architecture System, or CAAS, provides the crew with a fully integrated glass cockpit. CAS allows for seamless integration with other Army aircraft, enabling shared situational awareness across the entire air assault task force.
How does the pilot manage 2 massive rotors without them colliding in mid-air during extreme maneuvers?
The synchronizing shafts ensure the blades mesh perfectly, even if the engines are operating at different power levels.
Fuel management is automated through the Digital Advanced Flight Control System, optimizing fuel burn for the specific mission weight.
The Block II also introduces a new high-output electrical system, capable of powering future electronic warfare and defensive lasers.
Loading and unloading is facilitated by the COB, or Cargo On-Off Boarding System, which uses floor rollers to move pallets.
This system reduces the turnaround time on the ground, keeping the aircraft out of the enemy's sights for longer.
The Block II's triple hook system allows for tandem sling loading, which stabilizes large containers that would otherwise spin uncontrollably. Despite these mechanical marvels, the Chinook remains a high-maintenance beast, requiring 15 hours of maintenance for every flight hour. Maintenance crews must deal with the complexity of 2 engines and 2 rotor heads, doubling the potential failure points. However, the Block II's condition-based maintenance sensors provide real-time data to predict part failures before they occur.
This mechanical sophistication is the bedrock of the Chinook's combat reality, which we will explore next.
In the reality of combat, no system is perfect. The Chinook's greatest strength is also its biggest vulnerability, its size.
It is a loud, thermally hot target that can be heard miles before it's seen, giving enemies time to prepare.
To survive, pilots often fly nap of the Earth, using terrain features to mask their approach from enemy radar and visual observers.
The Block II's improved flight controls make this low-level flying safer, but the stress on the airframe is immense.
Failure condition. If the synchronization shaft is damaged by ground fire, the results are catastrophic as the rotors collide instantly.
Combat reality often involves brown-out landing, where the pilot has zero visibility due to kicked-up dust and sand.
The Block II addresses this with an integrated hover hold feature, allowing the computer to maintain a steady hover automatically. But technology cannot replace a door gunner's eyes. The Block II retains 3 M240 machine gun mounts for self-defense.
A significant limit of the Chinook is its lack of internal volume for troops compared to its raw lift capacity.
It is often volume limited before it is weight limited, meaning it can lift more than it can physically fit inside.
This is why the external sling load mission is the true bread and butter of the CH-47F Block II.
In maritime operations, the Chinook can perform pinnacle landings, where only the rear ramp touches a ship's deck or a cliff.
This maneuver requires incredible power management, as the front rotors are hovering while the rear weight is supported by the ground.
What happens when a Chinook loses an engine over a combat zone with a full load of ammunition?
The T55 engines have an emergency power rating, allowing the remaining engine to carry the load for a limited time. The operational reality is that the Chinook is a high-value target for enemy forces, often targeted by entire insurgent cells.
The loss of a single Chinook can mean the loss of over 30 personnel, making every mission a high-risk gamble.
To mitigate this, the Block II utilizes advanced flight path deconfliction software to avoid known threat concentrations automatically.
Despite the risks, there is no other platform in the world that can match the Chinook's heavy lift versatility and range. As we look to the future, we evaluate if these mechanical and tactical gains translate into long-term strategic value.
The strategic value of the Block II lies in its role as a force multiplier for the ground commander's maneuver space.
It allows the Army to maintain its current doctrine of air assault while waiting for the next generation of tilt-rotor aircraft. Economically, the Block II is a hedge against the high development costs and technical risks of the future vertical lift program. By upgrading existing airframes to the Block II standard, the U.S. Army saves billions in research and development expenses.
However, the international market is shifting. Rivals like the Russian Mi-26 offer more raw lift, though with less technical sophistication.
The Chinook's advantage is its ability to operate from carrier decks and small clearings, where the Mi-26 is too large.
Future impact includes the integration of autonomous flight modes, potentially allowing the Chinook to fly supply missions without a crew.
This would revolutionize logistics, removing the risk to human pilots in high-threat resupply runs to the front lines.
The digital backbone of the Block II ensures it can receive updates to its mission systems for the next 30 years.
Will the Chinook ever be truly replaced, or will it become the B-52 of the helicopter world, flying for a century?
Current projections suggest that even as tilt-rotors take over the speed mission, the Chinook will remain the heavy lift king.
Its tandem-rotor configuration is inherently more efficient at hovering with heavy loads than any other existing aircraft design today.
The cost of failure is high, but the cost of not modernizing is the obsolescence of the entire air assault capability.
As the Block II enters service, it brings a renewed sense of confidence to the soldiers who rely on it for survival.
Strategically, the CH-47F Block II is not just an aircraft. It is a global logistics platform used by over 20 nations.
This global fleet creates a massive logistics and spare parts network,
further reducing the operational burden for each individual operator.
In conclusion, the Block II is a masterful refinement of an aging design, balanced perfectly between cost and capability.
It remains the backbone of heavy lift, a testament to the enduring power of tandem rotor engineering in the modern age.
As we close this analysis, the Chinook continues its mission, hauling the weight of the world on its twin rotors.
Thank you for joining KL Warfront. Stay tuned as we continue to analyze the systems that defied modern combat.